In this unit, we will briefly discuss the facets that make up the subject of information security. At the end of this unit, you'll be in a position to outline the key knowledge areas that typically make up the information or cybersecurity area, as well as the surrounding knowledge that you may need to engage with as a security professional. Today, the scope of information or cybersecurity is still being defined. There are a number of international efforts that are seeking to determine what should be in the curriculum of a cybersecurity undergraduate or master's degree. A major effort is from the Association of Computer Machinery, which has a joint task force that was launched in 2015, consisting of several major computing societies. It grew out of the cyber education program in the United States. One of the societies that has been looking into this area for a long time is IFIP, the International Federation for Information Processing, who have a working group on information security education. This has been running since 1991, and its goal is to promote the information security education and training at the university level and in government and industry. As we saw in the previous section, the ACM Joint Task Force defines cybersecurity as a computing-based discipline involving technology, people, information and processes to enable assured operations. It involves the creation, operation, analysis and testing of secure computer systems. It is an interdisciplinary course of study including aspects of law, policy, human factors, ethics and risk management in the context of adversaries. So what are the knowledge areas that have been identified? The first is cyber defense, which includes aspects such as cryptography, computer security, network security and information assurance. We provide an introduction to these in this course. The next is cyber operations. This covers cyber attack and penetration testing. In penetration testing, we play the attacker so that we understand what can be done to a system. We also include here reverse engineering and cryptanalysis. Next is digital forensics, which includes hardware and software forensics on hosts and servers, mobile devices, right down to embedded systems such as set-top boxes. Here we are looking to identify incursions into our systems by attackers. In this area, we also see incident response, cybercrime and cyber law enforcement as part of the curriculum. Cyber physical systems, such as supervisory control and data acquisition, so-called SCADA systems, the Internet of Things, and industrial control systems move us out of the office and into the factory. And this is an essential part of cybersecurity because a lot of value is created in the factory setting. The next is secure software development. And this includes a number of different factors such as secure systems design, secure coding, deployment and maintenance of a system, and importantly, the usability of a secure system. We of course wish that all software was secure and usable, but that of course is not the case. Cyber policy, governance and law is the next. There are a range of regulations that apply for cyber systems and operations. And of course, cyber laws are very important to us as individuals as well as to organizations, such as the Data Protection Act. Cyber risk management includes cyber resiliency and assurance. For example, we need to think about disaster recovery and business continuity as an organization. How do we achieve this in the face of an attack or a failure of a system? In this, we also have security evaluations, and we need to consider cyber economics as an integral part of the curriculum at this point. The last knowledge area is human behaviors relating to cyber systems and operations, such as the use of social engineering by attackers who use social networks to infiltrate our organizations. In addition, user experience and organizational behavior are essential to understanding and developing secure systems. You can see that information security is a multidisciplinary area of study and of professional activity. We are concerned with the development and implementation of secure mechanisms of all types: technical, organizational, human, and legal.